we're going to do is learn how to solve log equations and inequalities. So looking at your notes, the first sentence is about if log base b of x is greater than y. Okay, and your base has to be greater than 1, x is greater than 0, which you can assume that that's going to be the case for these inequalities. The way you set up the answer is you keep the x value on the left side of the inequality, keep the inequality at the same, your base to the power on the right side. And that's how you set up your answer. Okay, after you evaluate, we're going to do this with numbers so you'll make more sense of it, but this is just a generic form. So the numbers that you get here, x has to be greater than, needs to make this x a positive number. Okay, so that's the hardest part about this whole section, is the base and that x value need to stay positive. Your exponent y, that can be a negative value, but whatever you plug in for x over here, that has to be positive. Okay, so the second sentence is when you have a log that is less than a number, the way you set that answer up, since it's less than, you have to have a bottom value that it can't be below. So 0 is going to be less than x, less than b to the y. So the base to the power is always on the very right side. Either one. It's just if it's less than, you have to have that bottom value. Okay, and if two logs are the same base or equal, then their parts are equal as well. That's the last sentence. So let's do some examples. On number 1, log base 36 of x equals 3 over 2. So this is written in exponential form. I'm sorry, it's written in log form. I can't really evaluate what x has to be to make this a true statement in log form, so I'm going to rewrite it in exponential form. Okay, your base is 36, the exponent is 3 over 2, and it equals your answer, x. Okay, so this is a rational exponent, this 3 over 2 that we worked with last semester, if you remember. The bottom number, the denominator, represents the root, what root it has to take, and the numerator represents the exponent. Okay, so if I'm taking the square root of 36, let's just simplify it without typing it into the calculator. If you take the square root of 36, it's going to be 6. Okay, so you don't have the root anymore because you took the square root of it. Then 6 to the third is 216. So x has to be 216. And as long as it keeps these values in your logarithm positive, they're good answers. Okay, so you guys do number 2 and I'll do it up here. Okay, so if we go through the problem, your base is 16, the exponent is 5 over 2, so a logarithm always equals the exponent, right? And then it equals x. This value is your answer. So I'm taking the root first. Square root of 16 is 4. 4 to the 5th is 1024. That's going to be the answer. Any questions? Okay, let's look at number 3. This one is different because you have a logarithm on both sides. You guys need to be paying attention.
This one's going to be hard.
This one, number 1 and number 2, you have just an expression in logarithm form. But this one you have a logarithm on both sides. So as long as the bases are the same, this is in base 2 and this is in base 2, you can reduce the logarithms out on each side and just set the parts equal to each other. You will not have a problem where the bases are different, okay? So you should be able to reduce those out every time that you have a problem like this. So you guys remember how to solve a quadratic problem for x?
Take the square root.
Oh, yeah, you scored
Oh, it's difference of perfect squares. So we can just simplify like that.
Well, yeah, it is right now, but I had this 3x over on the other side, so what do I need to do with the 3x?
Oh, get it off 0.
Yeah, I need to move everything over to one side and set it equal to 0. So I'm going to subtract the 3x, set it equal to 0, and now I can factor. 2 factors of negative 4 that add to be a negative 3. Negative 4 and positive 1. Since your leading coefficient is a 1, you guys need to listen. Since your leading coefficient is a 1, then you don't have to expand your middle term. You can just go ahead and break it down into binomials. X minus 4 and x plus 4 equals 0. So after you factor, the next step to solve for x is to set each factor equal to 0. And solve. So you have x equals 4 and x equals negative 1. Then you have to check your answer. So when I substitute the 4 in to my x squared minus 4, I get 12. When I substitute it into this 3 times x, I get 12. So that's a good answer. They're both positive numbers. If I substitute a negative 1 in to this first group, x squared minus 4, I get negative 3. When I substitute it in over here, I get negative 3. You can't have negative values for those answers, so you have to throw out the negative 1, and you're only going to use the x equals 4.
Oh.
Yes?
What equation did you do?